Hey, hello everyone. This is the week three of our session, and I'll just have it recorded. I'll just have a recap of what we've done. Week one, we went from introduction to Power BI, and last week we treated data cleaning and data transformation in Power Query, and they will be moving to data modeling in Power BI. So at the end of today's class, you should have um, the overview of the class today is basically understanding data modeling in Power BI, Power BI data model components, creating and managing relationships with Power BI, and schema design. Most of these you tell it in SQL. So because we're going to have a practical class, I'll try and refresh our memories on all these things before we do a practical class, data modeling in Power BI. So at the end of this class, you should have gained a solid understanding of what data modeling is and why it is crucial in Power BI. You learn how to create and manage relationships between tables effectively, and you also understand the principles of star schema design and snowflakes too, and how it benefits your analytics. So basically, data modeling refers to the process of designing a data structure that neatly organizes data in such a way that it's optimal for analysis. Um, it has to do with defining how different data elements relate with one another. When we're talking about data elements, we're talking about the tables you have. Most of the times, you don't have a flat schema. That's everything is not in one table. So you might want to connect one table to the other before you be able to get a reasonable insight. So why is data modeling essential? Not just in Power BI as a data analyst. I know we've treated SQL and we also treated Excel before this Power BI class, and we already know the basic principles of data modeling and why it is essential. So the number one reason is combining multiple data sources. Your data is not always from one source. Most of the times you get a data from web, and you have another template that is already on CSV. You might want to create a relationship between those two data so that you'll be able to get connected insights, so that you'll be able to get reasonable insight, like I said. And the second one is efficient data analysis. If you do not structure your data model well, you will not be getting a reasonable insight. Uh, and creating data model also has to come with doing it well. If you don't have a well-structured data model, you'll be having an insight that doesn't make sense, or an insight that is misleading to your stakeholders. So improved data visualization, the same thing with I said about efficient data analysis. When you create a good data model, you are able to get insights. You're able to generate a chart that is related to another. Let's say a sales rep is on another table, and the sales they generated is on another table. So if you're able to link those two tables together, you can be able to create a chart that gives you sum of sales for each sales rep. That's if you're able to connect the relationship between the two tables. And the next one is enhanced performance. When your data is properly modeled, it can improve the performance of your Power BI reports. Like like I said last week when we talked about the long data and the wide data, if you have a way of reducing the number of columns you have in your data set, please do so, because the more columns, imagine running a data set that has 100 columns and maybe 1 million rows, and you run a data set that has just 3 columns and 1 million rows. You can imagine the one that is going to perform better. So there are various ways you can reduce columns in your data set. You either use convert it from wide to convert it from wide to long data. That's where you apply your pivot in it. Or if it's a data that you can denormalize, you can be able to fit it in different tables. Another one is flexibility in reporting. So Power BI data model components. We have like four components in Power BI. Talk about the entity. This is basically referring to the tables, right? So, for example, entities might include customers, orders, and products. That is when you are dealing with sales data sets. So your attribute is referring to example the columns you have in each tables. So an example I left here is for your product table, that product table is your entity. Then the attribute in that product table is referring to the product ID, the product name, and the price. So the next component we'll be talking about is relationship. So this defines how tables are related to each other. I put entities in the slide, so I'll basically be saying tables because that's the one you can easily relate to, but just so that your entity is your table. So relationship define how tables are related to each other. For example, another table might be related with the customer table through the customer ID column. All these things you've done it in SQL. I'm just trying to like brush through everything before we do the data model in Power BI. And now we talk about the cardinality. This is referring to the relationship you just did. So you want to be sure if you are dealing with a one-to-one if you're dealing with a one-to-many relationship or many-to-one relationship, or there's many-to-many relationship, right? So creating and managing relationships. So creating and managing relationship in Power BI desktop has to do with identifying relationship. That's knowing the kind of the cardinality, whether it's one to many. Identifying relationship is basically knowing where the two tables are related. If um the simplest way of doing this is the IDs, right? Most data sets, once they have IDs, you just have to look twice. You know, that if the IDs is what you can use to link when you have your primary key and your foreign key. If the IDs is what you can use to establish that relationship between them, that has to do with identifying relationship. Then you talk about creating the relationship. This is basically drag and drop. Almost everything in Power BI is basically drag and drop. So go over this one next. And the next one is to set the cardinality. So after you identify the relationship, you create the relationship. Now you are setting the cardinality. And you have to be sure if you're dealing with one-to-one or one-to-many, many-to-one, or many-to-many relationship based on how the data in the table correspond to each other. So for schema design, a schema refers to the structured organization of data tables and the attributes and the relationship between them. A schema is more like a diagrammatic representation of your model. So there are three basic types of schema we have, especially in Power BI. So you can talk about the flat schema. So in a flat schema, all data is stored in one large table, no separate dimension tables. Most of the data you use to work. Oh, I think I might be talking fast. I'll just so most of the data you are working with in one table. Mostly the data at this stage, most of the data you work with, we call it flat schema. So you do not need to establish a relationship. Everything is in one table. So you just go ahead and do your visualization. But most of the times it doesn't come this way. Or if it comes this way and you have a lot of columns, you might need to disintegrate your columns or like separating the flat schema into if you want a snowflake or if you want a, a flat schema. The next one is the star schema. In a star schema, you have a central fact table connected to one or more dimension table. The fact table contains quantitative data. When we're talking about quantitative data, we're talking about numbers, right? So the fact table basically contains the numbers. While your dimension table, it describes your facts table. So you're having something like date, customer information, the sales rep information. It's more like a description, more description of what's contained in the fact table. So it helps separating your data into facts and dimension table. It helps to reduce data redundancy, right? Instead of having repetitions, you can just separate those things and put them in their dimension table and leave just the sales in your and leave just the numbers in your fact table. Then when we talk about snowflake schema, is an extension of the star schema where dimension tables are normalized into multiple related tables. It's more like a dimension table is related to another dimension table. There's a kind of schema that cannot directly connect it to the fact table. So for it to connect to the fact table, it connects to another dimension table that will now link. That dimension table may link to another dimension table, but at the end, it's going to the fact table. So this is like a pictorial representation of your star schema, where you have your facts table at the center and you have your dimension tables directly connecting to the fact table. This is the mostly the ones that is mostly used, apart from the flat schema. So the next thing that is widely used is star schema. Then this is the pictorial representation of the snowflake schema. So here you're seeing that this is a fact table. It's connected to a dimension table. So like we said, the snowflake is an extension of the star schema, right? So this is our star schema. This is the snowflake schema. You see here, if this first four, if you're removing these ones that are connected to this dimension table, this is your star schema. Now you're seeing another dimension table connected to a dimension table that is connected again to another dimension. So that's basically what I was describing. So basically we'll go over trying to do a data modeling in Power BI. I'll open my Power BI now. We'll be working with the popular superstore sales data set. Power BI desktop. Still coming up. So, so I'm going to click on get data profile, an Excel file. So I'm just going to pass. That's just going to, okay. This is the table I need. Now click on transform data. So here we are. This is because we want to normalize this table. The concept of normalizing this table is to get to separate the entities in this table. I want to get, okay. So you see that in this data set we have 22 columns and quite a number of rows. So we have the order ID, order date, the ship mode, and and every other thing. So basically, I want to separate this big table into smaller segments so I can get to model the table. So I can see that I have the order information, I have the customer information, I have the country, city, state, and postal. I have the product information. So what I'm just going to do is I'll duplicate this table. Now I want to first of all extract the customer table. I want that table to have everything that has to do with the customer, just the customer description. So here I can see customer name, I see customer ID. I'll click and hold on my control. I'll click on customer name. Is there any other thing that has to do with customer? Country, postal, product name, sales quantity, person. Yeah. Okay. This product sales, product name. I don't have salesperson ID. Okay. I think this is not the data set I meant. Let me check. Oh, that one is on my download. So I'm just going to on my download. Okay. So others. So I'll duplicate this. I'll get the customer name and customer ID. Um, Nothing else about the customer. I'm not muted. So I'll delete every other column. So I'll remove other column. I'll rename this customer. So what I'm just going to do, since this is my table about customers, so you can see that a lot of things are duplicated because I I got it from this others that has a lot of you're seeing because of the order and the profit and everything. So a particular customer might order like 10 times, right? But in the other table, I don't need this. So I'm just going to right click here and I'll remove duplicates. So I want to have a unique customer ID in this second one. So when I'm creating the relationship, it's going to be a one to many, right? The customer ID table does not need the customer ID to be duplicated because I just have the customer ID and the customer name. So I wouldn't be having the customer ID and the customer name being repeated like this. I can clearly see that I have duplicated value. So I will just right click here and I'll click on remove duplicates. That's done. So I have 793 customers. The same thing, I'm going to come to this other table again and I'll duplicate it. So I've worked on the customer ID and on the customer, so I'll delete everything. So um, I'm having the country, the city, the state. So these are information about location, right? So this one that I just did, this duplicate. So let me just name this the location. So the information we have about location here, so we have the country, we have the city, state, the postal code, we have the region, right? So these ones that I've selected, do we have any other thing on location? Okay, nothing. So I'm just going to right click here and I'll remove other columns. So what do you think should be our primary key here? So our postal code, because every region has a unique postal code, right? So country can be duplicated, city can be duplicated, states and region. So I'm just going to remove duplicates here. So that works well for it. The postal code. So we have our location now. We have our customer. So let me see other information we can extract. Ship mode, customer ID, customer name, segment, country, postal code. Okay, about products. I'm going to duplicate this. So I'll look for information about products. So I'm seeing product ID, category, subcategory, the product name. Okay, 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 that works. So I'll remove other columns. So I have the product ID, the category, subcategory, the product name. So I just have to confirm. Let me click this segment. So just going to come on here. I will edit it. So I need the segment on the product too. So I'll do the selection again. Select this segment, product ID, category, subcategory, product name, and I'll remove other columns. So the main identifier here is the product ID. So I'll just click on it and I'll remove duplicates. I'll rename this product. So I'll come back to this other table um and I'll delete some of the columns that I've already moved out. So I'll just leave the IDs, right? So I'm leaving customer ID, customer name, segment is going, country, the city. So this information now, I already have them in the other tables. So I can leave postal code. It's one of my identifiers. So region, I need product ID, category, product name. Oh, selecting. I'm just going to select every region. Where is the why does it keep selecting? So now we are left with the order ID. So I'll just bring the identifiers first. The customer ID, um, the product ID too. Bringing it, and the postal code. So it's allowed to be duplicated in the fact table because in the fact table is not a duplicate basically because we are having the sales. So a particular customer can make sales like 10 times. So what we basically did, we just reduced this table to 11 columns instead of having 22 columns. So basically, the one of ship, the ship details, if I have the ship ID, you can still move it and have another table so that you can be able to link the details to the fact table. So I'm just going to leave it here because I have not assigned um details to there is no detail assigned to the shipping um anything about shipping. So now I'm going to close and apply it. So by default, Power BI establishes the relationship between tables, right? So I'm just go after everything. I will remove the relationships and we'll do everything from scratch. So it's creating the connection in model. So if I go to the model view, this is what I have. You see, Power BI has done the connection for it. So the other table is the fact table here. So these lines you are seeing is the connection. So this is the design of it. This is the schema design, and you see that this is a star schema. So I'm just going to right click. So what I'm doing basically is I'm in the model view, like we said in the first week. So this is the model view. So I'm just going to right click on this. I want to delete it so create the relationship ourselves. So you see how you can create the relationship. So I just deleted this. I'll delete this one. So like I said in the presentation, the first thing you do is to identify the relationship. So you know that the tables we created out of the fact table that it's unique. So that's one. Every the ID is one. So in the others table is duplicated. So we are dealing with a one-to-many relationship here. So this is location table, and we can connect the location table to the others table via the postal code. So I'm just going to drag this one here and drop it. I'm going to merge it with this postal code here. So when I do that, it maps a line. So writing one to ash. So what to start, what this basically means is you're having a one to many relationship. If it's a many to many relationship, you are seeing a star to star, right? So now this is a one to many relationship. It doesn't matter the order you do the dragging, right? I dragged from the dimension table to the other the fact table. So now I want to drag from the other table, which is the fact table, the customer table. So you see that it doesn't matter the order you drag it from. So they are related in the customer ID. Oh wow. Ah, I thought I deleted it. So this is the customer ID. I'm going to relate it to the customer table. So we are having many to one relationship. So if you are going from the fact table to the dimension table, you have many to one relationship. If you're going to this dimension table to this, you have one to many relationship. So I'm just going to do the same thing for the product table. And we have our relationship. Now, if I want to make a plot and I want to know the product category that has the highest sales, I can easily get that. Now, if I don't have this relationship, I'm going to delete this and you see the reason your data model is important. If this relationship is not established and I come to the model, the code view, talking about products and the category, right? So I need product category and I'll now go to sales and I select sum of sales for each product category. So you see what I'm having here. It's giving me everything equal. Everything is 2.2 million. Now, if I come back to my model view and establish this relationship between the order table and the product, and I come back to this report view, you see that something has changed. I'm seeing that technology has more sales than furniture, and furniture has more sales than office supplies. So you are seeing the reason why you need an effective data model for your reports. So that being said, now we're talking about managing the relationship. You can either right click and click on properties for each of them. So you are seeing the table. This is order table to customer table. And you're seeing cardinality, whether it's many to one or it's one to many. If you select one to one, it's going to tell you that the cardinality you selected is not valid. And if you select a one to many, it's telling you that it's not valid because you're going from the order table to the customer table. So from the order table to the customer table, it is order to the customer table. Yeah, it is many to one. So this is the only time it is valid. So when you click on OK, this is what you have. Or you either go by right clicking or you click on this page, manage relationship. So this relationship is active from the order table to the customer table. If you remove this link and you click on I want to remove the orders to the product table. So we get to see that you are trying to make the deactivate the relationship. So when you deactivate the relationship, you see this is the dotted line. The relationship is there, but you've deactivated it. Makes it a dotted line, which affects your reports too, right? So you have to make sure that the relationship you have here is active. I can still come here and activate this relationship. So this changes um to a full dash, right? And your relationship becomes active. So I think we've covered what we talked about, the objective of today's class. So we talked about the cardinality, we talked about the snowflakes. So the data set we are working with is a data set that we can achieve a star schema with, but we can't achieve a snowflake. If I want to achieve a snowflake, I'll probably just put the customer ID. I'll remove the customer ID if I want to achieve something like a snowflake here. So I'll remove the customer ID from this other table and put it in location. So as I'll connect the customer to the location and then connect it to other ID. Or the snowflake, the star schema is always more effective. So it only works when you cannot link the table directly. You now get to attach it to another dimension table. So you guys will just watch, go through the videos. If you have any question, we'll get to handle the questions. That would be all for today's class.